Yo, 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 yo. All right, we're going to start working on transforming our absolute value functions even more. So we have talked about the parent function quite a bit of the absolute value function, which is just absolute value of x. We have also done problems where we had a number in front of our absolute value symbols that's being multiplied, like 2 times the absolute value of x. What we're going to do is we're going to add a couple more wrinkles to it and change it even a little bit more. So here's our main formula for the absolute value function. Now, what we've already worked with is this a value. This is the slope, really, but it's also known as the vertical stretch or compression of the graph. So it makes it skinnier, it makes it wider. Now, what we're going to do is we're going to come back and add to this. We're going to figure out, well, what is this value and this value? How does this affect our absolute value function? So that's what we're going to get into now. So let's look at some examples here. So now I have the absolute value function of x, and I'm going to put my parent function on here just so we can see what happens. So this right here, this is our parent function of the absolute value of x. So this is just the absolute value of x. Now, what we're going to do is we're going to see what happens if we subtract 4 afterwards. So we're going to use the same values that we've been using. Let's use -2, -1, 0, 1, 2. We're going to solve the problems and we're going to figure out what our y values are, and then we're going to graph and see what does this -4 do to our initial absolute value function. How does it change it? How does it transform it? So when I plug in -2, I have the absolute value of -2 minus 4, absolute value of -1 minus 4, 0 minus 4. Okay, so I'm filling out my table so we can see what our new points are so we can get values that we're going to graph. Well, 2 minus 4, that's -2. 1 minus 4, that is -3. And then let's see, 0 minus 4 is -4. 1 minus 4 is -3, -2. So this is going to give me our following points. Now, these are what I want to graph to see what happens with my graph here. How did this -4 change the absolute value function? So -2, -2. -1, -3, 0, -4, and then we went up the other way. So now this is what my graph looks like. So if we look, we have the exact same shape of a V, right? It's because we didn't multiply by anything, so we didn't vertically stretch or compress it. We didn't make it skinnier or wider. But what happened is our vertex is no longer 0, 0. It looks like the whole entire parent function from this -4 was shifted down 4. So this -4 on the end made the whole graph go down. So it moved my vertex down 4. So let's go back to our original formula. This k right here, this is a vertical shift. It's going to move the graph up and down. Okay, so this k is going to move the graph up and down. It's going to be a vertical shift, and it's really moving your vertex. It's really moving the vertex up and down. Okay, so now let's look at, well, what happens if I have the -4 inside of the absolute value brackets? So let's look at what this is going to look like, and let's use our same points just to see what happens here. So now I have -2 minus 4. Well, that's going to be 6 because this is -6. Absolute value of -6 is 6. -1 minus 4. That's a -1, not a 4. That's going to give me -5, which is going to give me 5. All right, well, if I did 0 minus 4, that's going to give me -4, which is 4. So get to the point 0, 4. If I plug in 1 minus 4, that's going to give me -3, which is the absolute value of -3 is +3. And if I plug in 2, 2 minus 4 is -2, which is +2. So this is going to be interesting because we don't have any repeat y values here. If I go -2 to +6, -1 to +5, So here are all my points. Right now I just have a straight line. So that's not good because we want to see our shape of a V. So what I'm going to do is we're going to continue this table until we see we start having a V here. So this is 3 minus 4, which is -1, which is 1. So that's going to give me this point right here. 4, absolute value of 4 minus 4 is 0. So now we're back now 0. I still have a straight line. But now when I go to 5, I have absolute value of 5 minus 4. Well, that's going to give me 1. And the absolute value of 1 is 1. So I go 5. Now we're going to start going back up. And it's going to continue going back up. So now the V goes like this. Now this is going to continue going up. So what happened is by minusing 4 inside the absolute value brackets, we shifted our graph, our parent function. Normally we start at 0, 0. So our parent function is normally right here. This is just absolute value of x, right? But we shifted it to the right 4. So the inside the brackets, this value is the horizontal shift. So this h right here is your horizontal shift of the vertex. So this h value inside the brackets is going to move your vertex left and right, where the k is going to move your vertex up and down. Now notice how in the formula it's minus, it's a negative symbol here. And notice how when we did -4, it shifted us to the right, which is normally +4. Well, that's because of the minus symbol the negative symbol in our formula. So really, it's the opposite. So if it's going to be in our actual equation, if it's negative, it's moving to the right. If it's positive, it's moving to the left. So this horizontal shift is always going to be the opposite of what it shows. It's a little confusing at first, but we'll show some examples here. So really, guys, the vertex, let's write this somewhere where it will be easy to find. The vertex is always going to be whatever the opposite of the h is and the k. The k is not the opposite, it is the same. That is going to give you your starting point right away without having to make a table. Okay, so now we have an h and a k. So just by looking at this right here, I should be able to find my vertex. It's the opposite of whatever's on the inside. So because it's +2, it's actually -2. And then it's whatever's on the outside, -1. So -2, -1. There's my vertex. Okay, now let's see if that's going to give us our vertex if we start from here. So if I go -2 plus 2, that gives me 0 minus 1. That does give me -1, -2, -1. If I go -1, -1 plus 2, that's +1 minus 1. That gives me 0. So -1, 0. If I go 0, that's 0 plus 2, which is absolute value of 2, just 2 minus 1 is 1. So now it's going to keep going up. We're going to keep trending up this way. So let's see what happens if I plug in -3. Because we see that the V is going to open up where it's this way. But now I got to see what happens to the left of this vertex point. So if I did -3, -3 plus 2, that's -1. So the absolute value of -1 is 1. Minus 1 is 0. So this is why this is the vertex, because now it's going to also continue upwards to the left. So we shifted it to the left 2 and down 1. There's our vertex. And then we use our vertical compression of up 1 over 1 because there's nothing there. Okay. And then now just a nice little quick reminder on what happens if I have a fraction here in front of my absolute value symbols. So what I think I wanted to show you guys is this is just your slope. So first I want to identify whenever I graph an absolute value function, what is my vertex? Well, there is no h and k, so my vertex is 0, 0. So I can start my graph at 0, 0. We're not going to make a table for this one. Now that I know my vertex is 0, 0, I'm going to use this value as my slope. Up 1 over 2. Up 1 over 2. And then this line of this axis of symmetry here, because my vertex is going through 0, 0, x equals 0 is my axis of symmetry. So that means this is a mirror, and I can reflect all of these points on the other side of that axis. So because I went up 1 over 2 here, I'm going to go up 1 over 2 to the left. This is 4 away, which means it should be 4 away from the axis of symmetry on both sides. So I made the 1/2 made the V a little bit wider. So here's what I want you guys to do. I want you guys to graph this absolute value function on your own. There's no space to make a table. See if you can do it without making a table. However, if you need to make a table, make a table. That's fine. Okay, but I want you to graph this function on your own, see how you do, and then unpause the video, and then let's check our work. And then I also want you to write down the domain, the range, the vertex, and the axis of symmetry. So pause, try it out. Okay, so I am going to graph this without making a table. So first what I want to do is I want to find my vertex. Well, my vertex is just negative hk. So I got to take the opposite, this inside the absolute value brackets, I need the opposite value. So because this is -1, my vertex is going to start at +1. And then I take the k value is my y. So my vertex is at 1, 4. Now what I want to look at is my graph going to be opening from here. Is it going to be opening upwards or downwards? Well, because this has a negative symbol, it's going to be opening down. And because it's -2, that's my slope. 1, 2 over 1. 1, 2 over 1. 1, 2. And then this, I'm going to draw a dotted line going down the middle here. This is the axis of symmetry. It always goes through the vertex. So the axis of symmetry, because the x value is 1 on the vertex, the axis of symmetry is just x equals 1. So that means that all of my points on the right side have to be the exact same distance away from the axis of symmetry on the left. So this is 1 away, so it's going to be 1 away. 2 away, 2 away right here. 3 away, so 1, 2, 3 away right here. And that was just using my slope going the other direction. And there's my function. My domain is all real numbers because it still goes forever in both directions. But my range has now changed. My range is y has to be less than or equal to +4. The range is always going to be whatever the y value is of the vertex. And then we have to determine if it's less than or greater than based on if it's opening up or down. And that's it, we're done. So we shifted it to the right 1 because of the horizontal shift, up 4 because of the vertical shift here. And then we had to stretch it out a little bit because of the multiplier in the front. Now you might have to write the absolute value function by looking at a graph. So first, always start with the vertex. So I want to see if there is a vertical and horizontal shift, which there is. It goes to the right, which means we do the opposite, which is subtraction. And let's look and see what this vertex is. It's 4, 1. So that means this is going to be -4, and the outside's going to be +1. So that's the hard part. Now I got to figure out what's the slope because I got to figure out what's going to be if it's being multiplied by anything in front. So I find another perfect point. Let's say we went up 3 over 1. So there we have it. And it's opening upwards, so it's not negative. So always start with a vertex, plug that in, and then figure out how steep your function is. That's all I got for you guys. Okay, there's your things to remember. The biggest mistake is remembering that inside the absolute value brackets, that horizontal shift is the opposite of whatever sign is showing. Okay, guys, that's it. If you guys have any questions or need any help, you need to let me know. Good luck. Thanks for watching. Greedy us out.